Hello, students. Good afternoon. We begin our next part of electrostatics. So before going on fourth part of electrostatics, we just recap the part 3. In part 3, we have studied about electric dipole, in which there are two, you can say, charges. One is negative, another is positive. They are separated by a very short distance, and usually it is presented by 2A. So this system is called electric dipole. And then a term came for this electric dipole, that was electric dipole moment. And electric dipole moment is presented by P. This is a vector quantity, and that's why we present it here in this way. Vector P is equal to Q into 2A. And since this is a vector quantity, its direction will be from negative charge towards positive charge. So this is about electric dipole moment. Now, when we put this electric dipole in an electric field, actually it will experience a torque. It means it will rotate, and a torque will be experienced by it, that is tau is equal to P E sine theta, where P is dipole moment, E is electric field, and sine theta is the angle between vector P and vector E. So for today's session or class, we have to study the electric field due to an electric dipole. There are two situations or conditions. One is, axial condition, another is equatorial condition, and then we learn about graph of electric force and electric field, you can say. And then motion of charged particles in a uniform electric field. And then we do some numerical. So let us begin with the topic electric field due to electric field due to an electric dipole. In axial situation or at an axial point. So at first we define here what is axial point, and then we will derive here the expression for electric field of electric dipole. So to go for that, I'm going to take a dipole. Suppose this is the first charge, this is the second charge. The first charge is having minus Q, and the second one is having plus Q. Now, the distance between these two charges is 2A, and that's why you can say the distance from the midpoint is A and A. So the line that meets these two charges is called axis. And if I am taking a point on this axis, that point will be called an axial point. So I'm going to consider a point P here at distance R from the center of this dipole. So we consider here, a point P at distance R from the center of dipole, made of two charges minus Q and plus Q, divided by a distance to A. Now, if you were saying that I have to take a point P here, or let me have this figure here. On the next slide, I'm going to take the figure. This is a point charge minus Q and then plus Q. This is minus Q, the first one. It is custom to take the first one will be negative, and here is 2A, and that is divided in two parts. This is customary to take 2A, so that first part will be A and the second part will be A. And you are going to take a point P at distance R from the midpoint. So, in our previous classes, we have gone through that when a source charge is taken, an electric field will be produced, and the formula for that electric field will be E is equal to 1 upon 4 pi epsilon naught Q upon R square, and the direction will be away from positive source charge and towards negative charge. So we can show here the direction of electric field, as well as we can calculate the magnitude of the electric field. So I am going to calculate the electric field due to first charge. I'm going to take this one is the first charge minus Q, and plus Q is the second charge. So if I'm saying that the first charge will cause an electric field at point P, its direction will be, at first we show the direction, its direction will be towards negative. It was told by me in previous class that electric field will work towards the negative source charge, and if source charge is positive, it will work away from it. Since this is negative test charge, so source charge, so electric field will be towards it. I'm going to say that this is E1. Now, if I'm taking the second charge is positive one, and that's why the electric field at point P will be away from it. I'm going to say that E2. So E2 is the electric field due to the second charge, and E1 is the electric field due to the first charge. Now, we can calculate its value. If we can use this formula here, I can write E1 is equal to 1 upon 4 pi epsilon Q, because here I'm not going to take minus Q. I have told you earlier, in your previous classes, I have told you that when we calculate electric field and electric force, we have not to take care of charges, nature, positive or negative. If we have used it in sowing direction by the arrow, अगर हमने एरो से डायरेक्शंस को दिखा लिया है, तो हमें कैलकुलेशंस में नेगेटिव और पॉजिटिव लेने की जरूरत नहीं है. Okay, so I'm going to take here not minus q, I'm taking it only q because I have shown the direction of the electric field with the arrow here. Now, what will be the distance of this charge from this point? Say this is A and this is R. So the total distance will be R plus A whole square. You can say this is equation number 1. Now, when we are going to calculate the value of E2, we can write E2 is equal to 1 upon 4 pi epsilon naught and then Q divided by. Again, this is Q and I'm not going to take positive negative in, the calculation of electric field. Now, what will be the distance of this one? If this is A and this is R, so this distance will be R minus A. Now, you can, look at this E1 and E2. You can find that E2 is greater than E1 because E2 is having less, quantity in its denominator. So if I am using it, this one is less value and this one is having more value, and these two forces are in opposite direction. So what will be the resultant value if the two vectors are acting in the opposite direction? What will be the, you can say subtraction of those two. So we can deduce at point P, the resultant value of E will be E2 minus E1. And that's why it will be 1 by 4 pi epsilon naught and then Q divided by R minus A whole square minus 1 divided by 4 pi epsilon naught Q divided by R plus A whole square. Now, if I'm going to take the things which are common, Q upon 4 pi epsilon naught will be common. The things that will be in bracket will be R minus A whole square minus 1 divided by R plus A whole square. So when we solve it, we can have here E is equal to 1 upon 4 pi epsilon naught and Q here. Here will be, if you take LCM, it will be R plus A whole square minus R minus A whole square divided by R plus A whole square into R minus A whole square. This will be the total overall value. Now, you can take here Q upon 4 pi epsilon naught, and I'm going to simplify it. Here will be, when you square it and, does your all the things, when you do all the things here, here will be coming to you 4RA. And the things which will be in denominator will be R square minus A square whole square. This is the total value. So Then I'm going to take something here, I'm going to separate 1 by 4 pi epsilon naught, and then I'm going to write 2q into a, and then here will be 2r, and then here will be r square minus a square whole square. So you can write it here, E is equal to 1 by 4 pi epsilon naught, and then 2qa can be written as P. As I have told you earlier, that in your previous session, it was told you that P is equal to 2qa. So I'm going to put it here. 2qa is equal to P into 2 into R divided by R square minus A square whole square. This is the value of it. But you should know that an electric dipole separation is very, very, very less than R. Because in the definition, it is told to you. In the definition, it is told to you that when the two charges are of equal amount and opposite nature are separated by a very small distance, that will be called dipole. So simply you can say here that the separation is very, very small, and that's why A will be very, very small, smaller than R. And if A is very, very small, A square can be neglected in front of R square. So you can neglect this A square from here. Okay. And that can be written as 0. Then we can write E is equal to 1 by 4 pi epsilon naught 2 PR divided by R square will remain, and again we do the square, here will be R power 4. And then finally we have E is equal to 1 by 4 pi epsilon naught and then 2p divided by RQ. So this is your formula. So this is the derivation, very, very, very important derivation. Electric field due to an electric dipole at an axial point, you have to take a dipole, you have to show E1 and E2, and then you have to, solve it mathematically. Now you are getting here only the magnitude, not the direction. So if I am going to, make clarity of the direction from this figure, you can watch here. E2 is more, and E2's direction is towards right, and E1 is small. Sorry. Here it will be right, and this one will be less. E2 is more, and E1 is less. That's why you have done here E2 minus E1. अधिक में से कम को आपने क्या किया हुआ है, माइनस किया हुआ है. So when you got the resultant E, what will be the direction of E? तो जब दो वेक्टर्स होते हैं, the two vectors are opposite to each other, तो suppose राइट साइड को 10 न्यूटन का फोर्स काम करता, लेफ्ट साइड को 5 न्यूटन का काम करता फोर्स, then what will be the resultant? Resultant will be 10 minus 5 is equal to 5. And what will be the direction? So जिधर को बड़ा वाला फोर्स होगा उधर को ही होगा. So यहाँ पे भी जो डायरेक्शन होगा, you can write the direction is towards E2, and you can see E2 की डायरेक्शन उधर ही है. यानी अगर मैं एक डायरेक्शन डिसाइड करूं माइनस से प्लस की तरफ, तो जो डायरेक्शन माइनस से प्लस की तरफ है वही डायरेक्शन E2 की है. तो अगर मैं इसे लिखना चाहूं तो मैं इसकी डायरेक्शन को p कैप से दिखा सकता हूं, क्योंकि जो p की डायरेक्शन होती है वो माइनस से प्लस की तरफ होती है. So if I'm going to say that it is towards E2, vectorly we can write vector E is equal to 1 by 4 pi epsilon naught and then 2p divided by r cube into डायरेक्शन, और डायरेक्शन को दिखाने के लिए हम यूनिट वेक्टर्स लेते हैं. तो यूनिट वेक्टर कौन सा होगा? p का, कि जब एक वेक्टर का मैग्नीट्यूड उसके यूनिट वेक्टर से मल्टीप्लाई हो जाता है तो वो कंप्लीट वेक्टर में कन्वर्ट हो जाता है. एंड नाउ वी कैन राइट इट एज वेक्टर e is equal to 2p upon r cube. So this is the vector presentation of electric field due to an electric dipole in an axial situation or condition. If we, this is the first thing we got it here. Now we are going to derive the electric field due to electric dipole in equatorial position. So before going on that, I want to listen your doubts, your confusions. If you have any doubt, you can ask the question. I'm unmuting you all. Please, if you have any doubt, you can ask the question or write your question in the chat box. Any doubt? I'm coming to the slide. Ask any question if you have. Roshan, only you were unmuted. So have you any doubt?
Yes, sir.
Okay. बाकी सारे लोग क्या अपने वॉइस के साथ कनेक्टेड नहीं है क्या? चलिए, डाउट नहीं है तो हम अगले टॉपिक पे चलते हैं. द नेक्स्ट टॉपिक इज इलेक्ट्रिक फील्ड ड्यू टू an electric dipole at an equatorial position. Now we have to be very sure about equatorial position or point. When you take a dipole, suppose this is the dipole having minus q, I'm always saying you that this is custom to take the left charge to be negative. Now the distance between these two charges will be 2a, and you have to divide it in 50-50, means a and a. Now if you draw a line like perpendicular to this one, if you draw a line perpendicular to this axis, that separating it into two parts, then this line will be called equatorial line, or equator you can say. So this is equator. If you are taking any point on this line, that will be called equatorial point, or a point in equatorial condition or situation. So if you take a point here, at this point, anywhere, you can take a point on this line, that will be called equatorial point. You have to find what, how much amount of electric field is produced at these points. So we are going to find it out. How can we find it out? I'm taking a dipole, you know, dipole is having minus q and then plus q and 50-50 distances, 50 distance A and then again A. Now we have to draw a dipole, sorry, equatorial line. So I'm going to draw it. This is equatorial line, and I'm going to take a point here, point P. Now we are meeting the two charges to the point P, and then okay, now at point P, again we can say that there will be two source charges. The two source charges, the first one will be minus q, the second one will be plus q. Now we have to show the direction at first. What will be the direction due to minus q? The direction of electric field, I again repeat it, due to minus charge, what will happen? Due to minus charge, Prabhat, kindly mute your background audio. Prabhat, mute your audio, please. Okay, so when this one is minus negative q charge and electric field will be towards it. Say this is E1 and due to plus q, there will be the electric field. There will be the electric field and that electric field will be away from it. So that will be in this direction. And you can write it as E2. So when you got the idea about the directions, you can go for calculation of E1 and E2. So if you are going to calculate E1, E1 will be 1 by 4 pi epsilon naught and then Q divided by the distance between point and the source charge. Point is here, this one, P is the point, and this minus Q is the charge. The distance between these two will be what? If I'm writing this one as A, this one as B, you can write here, it will be AP square. Now, if your point P is situated at distance R from the midpoint O, means PO is R, then you can write AP square is equal to AO square plus OP square by Pythagoras theorem. Okay, if you are applying Pythagoras theorem here, you can have AO is equal to A and then OP square means R square. So AP square is equal to A square plus R square. Now, in the same way, if you will calculate the value of VP, it will be VP square is equal to again A square plus R square. Now, so when we write or when we calculate E1, it will be E1 is equal to 1 by 4 pi epsilon naught and then Q divided by AP square means 1 by 4 pi epsilon naught Q divided by AP square can be written as R square plus A square. Now, this one will be E1. Say equation number 1. Now, E2 will be 1 by 4 pi epsilon naught Q divided by, again, you can write here as BP square. When we put the value of BP, we can have, E2 is equal to 1 by 4 pi epsilon naught, and then Q divided by BP square value is again R square plus A square. So you can say that this is equation number 2. Now, we are having two vectors here. If we can see here, we are having two vectors, E1 and E2. E1 is in this direction. Let me have another figure. E1 is in this direction. Okay. E2 is in this direction. Done. Now, if we show the, direction by arrow, this is E1. This is E2. I'm drawing one horizontal line here. If I'm considering that this angle is theta, this angle will be theta. Why? This is alternate angle. So I can say that this angle is theta. Okay. If this angle is theta, A, then angle B will be theta because your AP is equal to BP. So this is, you can say, a triangle having two sides equal, and hence you can say that the two angles will be equal. And if this angle is theta, this angle will also be theta. And that's why we can say that this angle will also be theta. Now, resolution will take place. In this direction, you should know the resolution is from 11th class. 11th class में आपको बताया गया है कि कोई भी वेक्टर जिस डायरेक्शन के साथ एंगल बनाता है उस डायरेक्शन के उसकी डायरेक्शन में जो कंपोनेंट देता है वो cos थीटा मल्टीप्लाई करके आता है और उसके परपेंडिकुलर डायरेक्शन में sin थीटा मल्टीप्लाई करके आता है. तो E2 का इस तरफ का कंपोनेंट होगा E2 sin थीटा और इस तरफ का कंपोनेंट होगा E2 cos थीटा. Okay. In the same way, E1 will have same scenario, and that's why in this direction it will be E1 cos theta और इस तरफ का कंपोनेंट होगा E1 sin theta. Now, you can look at equation 1 and equation 2. E1 and E2 both are having same magnitude. And theta is same for both. So E1 sin theta and E2 sin theta both will cancel out each other because one is in positive y direction and one is in negative y direction. And that's why we can write it here. If we conclude from these, discussions, we can say that E1 sin theta and E2 sin theta will cancel out each other. And hence, at point P, the net electric field will be what? What can you say? Net E will be E is equal to E1 cos theta plus E2 cos theta. So when we do it here, we can have E is equal to E1 cos theta plus E2 cos theta. We can put the value of E1. It is 1 by 4 pi epsilon naught, and then Q divided by R square plus A square into cos theta plus 1 by 4 pi epsilon naught Q divided by R square plus A square, again cos theta. So we can write it as 2 into 1 by 4 pi epsilon naught Q divided by R square plus A square cos theta. Now, in your trigonometry, it is mentioned that cos theta is equal to base upon hypotenuse. So, when we take the help of previous figure, you can say that in triangle A, P, O. In triangle APO, this is the angle. So this one will be AO will be base and AP will be hypotenuse. And hypotenuse value will be under root R square plus A square. So we can write it here as cos theta is equal to, but cos theta is equal to what was base? A. And what was hypo there? It was R square plus A square. So we can write it here. E is equal to 2 into 1 upon 4 pi epsilon naught, and then Q upon R square plus A square into, put the value of cos theta. Cos theta is A divided by under root R square plus A square. So, you know that root means what? Raised to power 1.5. Yes, 1.5. Sorry, half only. So here will be 2QA, and 2QA is presented by P in your previous session. So we can write it as P, and here will be R square plus A square raised to power. One power is here and half power is here. So it will be 1.5 power. But you know, you have told that your R is very, very bigger than A, or simply you have told that your A is very, very less than R, and that's why A can be neglected. So what will be E? E will be 1 upon 4 pi epsilon naught. It will be P divided by R raised to power 3 by 2, because A square can be neglected. And then if you write the result, it will be E is equal to 1 upon 4 pi epsilon naught P divided by RQ. Now, this is its scalar value. If I have to write vector value, what will happen? See, in the figure, when you have done it here, you have told that the net electric field will be due to E1 cos theta plus E2 cos theta. And what is the direction of E1 cos theta and E2 cos theta? That is from right to left. If we compare it with this figure, from right to left means what? From positive charge to negative charge. And you have told earlier that dipole moment is having one direction, that is from negative to positive. तो अब इसका क्या मतलब हुआ? अब इसका मतलब ये हुआ कि P माइनस से प्लस की तरफ जाता है, जबकि आपका जो फील्ड आया वो किधर से किधर को हुआ? आपका राइट टू लेफ्ट आया, और राइट टू लेफ्ट का मतलब फ्रॉम प्लस टू माइनस आया। इसका मतलब ये P की जो डायरेक्शन होती है ये उसके उल्टा है, and that's why when you express it in vector quantity, your direction will be written as minus r cap, not plus r cap, because this is opposite, not r cap. You can write p cap, direction of vector P, and then you can write it as here. If I'm writing it here, I can write vector E is equal to minus 1 upon 4 pi epsilon naught, then vector P divided by r cube. So this is your final answer. Okay. Now we compare these two cases. You have told we are having two situations, one in axial and one in equatorial. When you have done the derivation for axial, you got the magnitude 2p upon r cube. Here, you can watch. And when you have done the derivation for this one, you have got p upon r cube. Means when you are on axis, suppose at distance r, and you are getting some value of electric field, then you move on the equatorial line at the same distance, your electric field will be half of the field which you got at the axial point. Okay, so first thing is इलेक्ट्रिक फील्ड एक्सियल पे ज्यादा होती है, इक्वेटोरियल पे कम होती है, और अगर आप डिस्टेंसेस सेम लेते हैं एक्सियल और इक्वेटोरियल पे, तो जितना एक्सियल पे मिलता है उसका आधा आपको इक्वेटोरियल पे मिलता है। ये पहली चीज है। दूसरी चीज ये है जो इंपॉर्टेंट है और नोटिशिएबल है, वो ये है कि when you are on axial axis, your electric field will be in the direction of dipole moment. It means आपका वहां पे इलेक्ट्रिक फील्ड नेगेटिव टू पॉजिटिव होता है, but when you are on equatorial position, your electric field direction will be from positive to negative. It means it will be opposite to the direction of electric dipole moment. So one year in 12th class board paper, it is asked what is the direction between electric field of an electric dipole in axial and equatorial position. So काफी टाइम लग गया बच्चों को मेक आउट करने में कि हुआ क्या, मतलब किसके किसके बीच एंगल पूछा जा रहा है। सो एक्चुअली वो एंगल पूछा गया था दोनों इलेक्ट्रिक फील्ड्स के बीच का। वन इलेक्ट्रिक फील्ड इज ऑर्बिटेड ऑन एक्सियल पोजीशन, वन इज ऑर्बिटेड ऑन इक्वेटोरियल पोजीशन, एंड इट इज वेरी क्लियर दैट जो एक्सिस पे होता है वो P के डायरेक्शन में होता है और जो इक्वेटोरियल पे होता है वो P के अपोजिट होता है। सो दोनों के बीच का एंगल 180 डिग्री होगा। नाउ again I'm ready to have your question. If you are having any doubt, any problem, you may ask your question. Any one of you? Most of you are logged in without your audio. So if you are not joined with the audio, you can write your question in chat box. If you have any doubt, you can write it there. You can ask, you can raise your hand. I can unmute from there. No one. No doubt at all. Chat box is also empty. This is very important question, topics for your 12th class. I'm assuring you that in your first unit test, you are going to have these two problems. Find the electric field due to an electric dipole in equatorial. It is, most hot spot. ये क्वेश्चन जरूर पूछा जाता है और डेरिवेट करना पड़ता है. तो you have the recap here. You have to make the figure, then you have to show the direction of E1 and E2, and then you have to write the value of E1 and E2, and then you have to resolve E1 and E2, and then E1 sin theta and E2 sin theta will cancel. Only E1 cos theta and E2 cos theta will be there. Those will be combined, and then you will get this answer. One more thing, important here, that we have to put the value of cos theta from the figure which we have made, that is a divided by under root r square plus a square, and finally you will get the final answer by taking a is very smaller than r, and then you get the formula. So if you are not having any doubt, I don't know why are you not having doubt, because this is very important topic. Roshan, again you are unmuted. Only you are unmuted. So do you have any doubt?
Yes, sir.
Very good. यार सारा समझ में आ जाता है ऐसे ही? नो.
आता है सर, समझ आता है.
Okay. So we are going on next topic जो हमने शेड्यूल किया था आज पढ़ने का, ग्राफ्स. Actually ग्राफ के काफी सारे क्वेश्चन. दिस ईयर it was, what you can say, disaster for the students. Many question of graphs are asked in the paper. और हम लोग भी when we corrected the paper there, we discussed day by day the pattern of the CBSE paper which being changed. So we have to be very aware of the graph. Actually, graph is taken by us to help the student to understand the concept. But आजकल प्रॉब्लम उल्टी हो गई. ग्राफ देख के बच्चे को लगता है ये कहां से आ गया. तो ऐसा नहीं होना चाहिए सिचुएशन. एक्चुअली फिजिक्स पढ़ने के लिए ग्राफ असल में मैथमेटिक्स का है, पर उसे फिजिक्स में इंक्लूड इसीलिए किया गया ताकि बच्चे को ग्राफ देख के ही समझ में आ जाए कि क्या होगा, वो घटेगा, वो बढ़ेगा, क्या होगा, कैसे घटेगा, कैसे बढ़ेगा. पर आजकल मामला उल्टा हो रहा है. ग्राफ देख के पसीने छूट जाते हैं. ओके, नाउ वी आर गोइंग ऑन ग्राफ. मैंने कहा था सबसे पहले हम इलेक्ट्रिक फोर्स का ग्राफ खींचेंगे. इलेक्ट्रिक फोर्स मींस इलेक्ट्रोस्टैटिक फोर्स. आपको पता है कि इलेक्ट्रोस्टैटिक फोर्स दो बातों पे डिपेंड करता है. पहला होता है, the first thing is on which the electric force or electrostatic force depend is the distance, another is the charges. So then we have to show the graph. We have to decide x axis. So we are going to decide here that this one is x axis and this one is, this one is y axis, suppose. Now on the x axis, if you are showing r, on the y axis if you are showing f, you should be very clear that there are two kinds of forces in the electrostatics. One will be attractive, another will be repulsive. So when attractive force will be there and when repulsive force will be there, you will say that when plus and plus there will be repulsive, when minus and minus there will be repulsive, when plus and minus there will be attractive, and when minus and plus there will be attractive. And force formula is 1 by 4 pi epsilon naught and then Q1 into Q2 divided by R square. It means Q1 is multiplied with Q2. If I'm doing here, taking here, this one is Q1 and this one is Q2. When you multiply Q1 and Q2 with the sign, what will happen? Plus with plus, positive. Minus with minus, again positive. It means if your force is positive, then this will be repulsive force. Means your plus F will show repulsive nature, your minus nature will show attractive nature. So if there is attractive force, it will be shown downward, and attractive force, it will be repulsive force, it will be in positive direction. So suppose if I'm giving you there are two system of charges, one is of +3 and plus 4 -4 coulomb or micro coulomb charge at some distance, say 10 centimeter from the origin, or the distance between those two are at 10 centimeter. And the same way, you can have here, 3 and then +3. Now plot the graph for the force, or you can say 1 and 2. So when you graph, the distances are taken same. If the distances are taken same, only the amount of force will be different and the nature will be different. So you can write that, suppose this one is, the complete one is K. Then what can you write? F1, I'm calculating it somewhere. Let me calculate. Okay, so I'm calculating here. F is equal to K, which is constant taken by me. Don't worry. It's a simply a notation I have taken, into +3 into -4 divided by, say, R is the distance 10 centimeter, whatever you will have be given here. I'm taking it R cube, R square. So it will be -12. If you were placing 1 here, so the total one will be negative, and that's why your force will be going downward. So when this one will be 0, 0 को छोड़ दें आप, 1 ले लें. So this force, the graph will be like this. R square. You have to take, let me correct it. If there is a square thing, then the graph will be little bit parabolic in nature. And here it will be positive in this way. So this is F2 and this is F1. So this is the graph of electrostatic force. Simply you can say, when somebody is asking, draw the graph for electric force with the distance, then you can say that this graph will be like this. As the distance increases, as the distance increases, the force will decrease, and that's why this graph will be like this. Okay, so as soon as R will be 0, the force will be what? Infinity. So this is, in the previous section, little bit different shape we will get here. It will be likewise. If distance is this one, this way, you can have. No? Like parabolic nature will be here, and this will be in this way. When R will be infinity, the force will be 0. So this is the graph, and here this will also be changed, and it will be actually the graph that I have drawn is for R square versus R square. So this is the graph for, you know, positive negative system. This is positive positive system. Commonly this is drawn in this way. Now for the electric field, if you have electric field due to a point charge, the formula is 1 by 4 pi epsilon naught q divided by R square. So same nature of the graph will be, here will be R, here will be F, and then your graph will be same way. This is called when you were in your 11th class, it was told that if there is one thing, you know, having one power and another variable having two power, then the nature of the graph will be parabolic. So it is from there. It is square graph. Now the next one, electric field due to dipole. In both the cases with R, when we can say the direction, the force variation with R will be, here will be the force, here will be the R. The rate of fall of force with the distance will be more, because, you know, you have written that in this case, electric field is directly proportional to R cube. In both the cases, axial and equatorial, in axial you have written E axial is equal to 1 by 4 pi epsilon naught, and then 2p divided by R cube. And in the case of E equatorial, it was 1 by 4 pi epsilon naught, and then p divided by R cube. So in both the cases, what happened? Your electric field is inversely proportional to R cube. So graph will be same, almost same, because as the distance increases, the value of E decreases. But it here, the E will decrease rapidly. So in this one, it was slanted one, here it is slanted one, here it is slanted one, but here if you go, it is deeper one. So slope of this graph will be more, and that's why this is the graph for electric field due to a dipole. Now the next topic that we discuss today in very short, motion of charged particle. In uniform electric field. Okay. So when we discuss about electric field, let me have, आपको पता है कि आप अगर इलेक्ट्रिक फील्ड को दिखाना चाहते हैं, then you have to show the electric field line. So if I'm showing electric field line parallel to each other, then we can say that this is an uniform electric field. If I'm putting a charged particle here, or throwing a charged particle here, suppose I'm having a charged particle here, what will happen? This particle, if I'm throwing it here in this way, or if I'm putting it here in this way, what will happen? It will feel a force. Suppose I'm having a charge plus Q here. So I'm saying that this is having a charge amount plus Q, then it will feel a force, and the force value will be F is equal to Q into E. At the day I have told you कि जब आप कोई positive charge किसी field में डालते हैं, it will experience a force in the direction of electric field. So what can we write here? What can we say here? Now, if I'm placing this charge, suppose this charge is stationary, Q is stationary. If Q is stationary, it means U is 0. If U is 0 and there is a force F acting on the charge, we can calculate the acceleration. A is equal to F upon M, that is QE upon M, where M is what? Mass of this body. And if we get it, we can have V is equal to U plus AT. We can calculate S is equal to UT plus half AT square. And we can have V square is equal to 2 square plus 2as. So we can find out using these many equations. Now the thing is different when we throw somebody from here. When we throw some particle perpendicular to the electric field. Suppose I'm sending one object here in this way, U, with the speed U. Now this will move in this way, and that is parabolic path. So when a charged particle is thrown or made to move perpendicular to electric field, its path will be parabolic. Okay, and we can prove it, like in your 11th class, you have proved that the path of projectile is parabolic. So वैसे आप इधर भी prove कर सकते हैं. Proof करने का तरीका we can prove it in next class, and we can solve a numerical in next class on this topic. So that's all for today. If you have any doubt, you can ask students. मेरी आप सबसे रिक्वेस्ट है, जब भी आप लॉग इन करते हैं वहां पे एक ऑप्शन आता है कि लॉग इन विद ऑडियो इनपुट कुछ लिख के आता है. सो प्लीज क्लिक यस देयर, और बाद में आप म्यूट हो जाएं ताकि हम यहाँ से अनम्यूट हो पाए. यस, देयर इज अ क्वेश्चन इन इनबॉक्स. Sir, if Q1 is stationary, this is the question from Pritika. Sir, if Q1 is stationary, will it experience acceleration? Yes, it will. It will experience, the acceleration, because acceleration is due to interaction of charge with the electric field. So suppose I'm taking this one Q1, this one Q2. Suppose. Okay, if Q1 and Q2 I have taken, in both the cases, the amount of force will be in the same direction. F is equal to QE. and hence the acceleration will be QE upon M, irrespective of whether this is moving or not moving. आप अगर यहाँ पे फेंकते नहीं, सपोज आप इसे थ्रो नहीं करते, तो फिर ये क्या करता है, ये यहाँ से सीधा सीधा चला जाता है. इसका मतलब इस सिचुएशन में जो पहली सिचुएशन है आपकी, इन दिस सिचुएशन this will move in straight line. If your Q is stationary, what will be the path? Straight line. और अगर आप फेक भी देते इसे, सपोज यू आर गिविंग स्पीड यू, तब भी इसका क्या रहता? स्ट्रेट लाइन. बट हियर इट इज डिफरेंट. अगर ये यहाँ पे स्टेशनरी है तो स्ट्रेट लाइन होगा, बट अगर आपने इसे फेक दिया तब ये पैराबोला पे चला जाएगा. So, any more doubt? Kritika, if you are getting answer of your question, write yes in chat box. Okay. Okay, beta. If some more question you have, you can ask. I'm unmuting you all, but unfortunately, you all have logged in without audio, and that's why you are not able. I'm not able to unmute you. So that's all for today's class. In the next class, the most important topic of this chapter, Gauss's law and its application, will be studied. Okay, till then you can do the numerical of electric field due to electric dipole. You can do the electric numerical on electric field due to a point charge. So many questions of NCERT. I have covered so many questions. So NCERT book, if you have, if you don't have, you can download it. Download it from directly way in your writing the. There is one portal, mobile portal of CBSE, that is ePathshala. So download this app in your mobile. Here you can have all the books in your mobile. All the books NCERT. Okay, in PDF format you can have, you can go there and you can solve the numerical from the exercise. Okay, so goodbye, and we will be back in our next session. Thank you. Okay.